Okay, today we're going to be looking at dependent events and conditional probability. So previously we've been looking at independent events, and for independent events we have the multiplication law. So the probability of A and B is equal to the probability of A multiplied by the probability of B. And two events are independent if event A and if the occurrence of event A does not affect on the is not affected by the occurrence of event B. An example of that would be rolling a dice. The probability of rolling any number doesn't depend on any other number being rolled. If you were to find the probability of rolling a 2 and then rolling an odd number, for example, those two are completely independent of each other. A dependent event is when neither can occur without being affected by the other. An example with that would be if you had a bag of different coloured balls, red and blue, and you wanted to find the probability of what's the probability of the first one being red and the second one being blue. Well, the probability of the second one is going to be affected by the probability of the first one, because you're changing the number of balls in the bag by taking the first one out. So the number of balls is changing. You might have, if the first one was blue, there's going to be fewer blue there. That makes sense. So the probability law for what we find is that this multiplication law here, this is a special case of the multiplication law for probability in general. So the general multiplication law is used to find the probability that this and that occurs when the events involved might not be independent. So the probability of A and B is equal to the probability of A multiplied by the probability of B given that A has occurred. And the probability of B and A is equal to the probability of B multiplied by the probability of A given that B has occurred. Now, what we can deduce from this is the probability of A multiplied by the probability of B given that A has occurred is equivalent to the probability of B multiplied by the probability of A given B has occurred. Let's look at some examples to see how this works. So, two children are randomly selected from 11 boys and 14 girls. Find the probability that the selection consists of, firstly, 2 boys, and secondly, a boy and a girl in any order. So the probability of 2 boys is going to be equal to the probability of B and B, which is the probability of the first child being a boy multiplied by the probability that the second one is a boy, given that we've already had 1 boy selected. So the probability of getting a boy, so how many children are there in total? So the total children is 11 plus 14, which is 25 children in total, and we've got 11 boys to begin with, and there's 25 children, so that's the probability of B. Now, if the first child is a boy, then there's only going to be 10 boys left to pick from, and we've already picked a child, so there's going to be 24 children left. So that gives us a probability. I'll multiply these out and then simplify down. We'll get 11 over 60. Now, B, the probability of a boy and a girl. Now the important part here is in any order. So we need to think, what are the different orders that we could have? We could have the probability of a boy and a girl, or we can have, so we've got, because we're doing a probability of one or another, we add the probability of a girl and a boy. So that's the probability of the first child being a boy multiplied by the probability that the second one is a girl, given that the first was a boy. Add that to the probability that the first one was a girl, multiplied by the probability that the second one is a boy, given that the first was a girl. So, the probability that the first is a boy, we've got the 11 boys over 25 children. That's going to be multiplied by the second one being a girl, so there's 14 girls. And now there's only 24 children because we've picked one already. The probability the first is a girl, so that is 14 girls over 25 children, multiplied by there's 11 boys and now there's 24 children. Working all that out, we get 77 over 150. Now, every Saturday, a man invites his sister to the theatre or the cinema. 70% of his invitations are to the theatre and 90% of these are accepted. his sister rejects 40% of his invitations to the cinema. Right, find the probability his invitation is accepted on any particular Saturday. So the probability that his sister accepts depends on where she's invited to go. So that shows us that this is a conditional probability. Now we can use the tree diagram to apply the multiplication law. So he's either going to give her an invitation to the theatre or to the cinema. So it says that 70% of his invitations are to the theatre, so this is 0.7. Therefore, this must be 0.3. We know that if it's a theatre, 90% are accepted. Oops, 90.9. Therefore, 0.1 must be rejected. We're told that she rejects 40% of invitations to the cinema. Therefore, 0.6 must be accepted. So, the probability that it's the theatre and it's accepted will be equal to 0.7 times 0.9, which is 0.63. Now we're interested in acceptance. So here is the branch here for acceptance. So the probability it's the cinema and it's accepted will be 0.3 times 0.6, and that's going to be 0.18. So the probability of being accepted is going to be this add this plus 0.18, which is 0.81. So he's got 81% chance of being accepted on a Saturday from this, with his invitations to his sister. Now we can use the multiplication law of probability to find conditional probabilities. So we know the probability of A and B is equal to the probability of A times the probability of B given A's happened. And if we know the probability of A and B, and we know the probability of A, we can know the probability of B given A. So the probability of B given A is the probability of A and B over the probability of A, and the probability of A given that B's happened is the probability of A and B over the probability of B, where the probability of A and B is equivalent to the probability of B and A. So, given that the probability of A and B is equal to 0.36 and the probability of B is equal to 0.9, let's find the probability of A given that B has happened. So the probability of A given that B has happened is going to be the probability of B and A over the probability of B. So we know these 0.346 over 0.9, and that gives us 0.4. Let's do another example. An ordinary fair die even is rolled. Find the probability that the number obtained is prime, given that it is odd. So we want the probability that it's prime, given that it is odd. So the probability of odd and prime over the probability of odd. Now, the odd numbers are 1, 3, and 5. So the probability of odd is going to be 3 and 6. The odd prime numbers are 3 and 5. So probability of odd and prime is going to be, there's 2 of them, over 6. So the probability of odd and prime is going to be 2 over 6 divided by 3 over 6, which is 2 over 3. Let's do one last question. A boy walks to school. 60% of the time and cycles 40%. He is late on 5% of the occasions that he walks. And is late 2% of the occasions he cycles. Given that he is late to school, find the probability that he cycles, i.e. we're finding the probability that he cycled given that he's late. So let's put this information into a tree diagram. So we've got our walking and cycling. and he walks to school 60%, so it's 0.6, and cycle is 0.4. When he walks, it's 0.5, so this is late, so it's 0.05, and not late is going to be 0.95. When he cycles, he's late, 0.02, and when he's not late, it's 0.98. So we've got here the probability of walking and late. It's going to be 0.03. Probability of walking and not late is 0.57. Probability of cycling and late is 0.008. Probability of cycling and not late is 0.392. So the probability of being late is going to be the probability of walking and late, add the probability of cycling and late. So this, add this. And that gives us 0.038. So the probability that he cycled, given that he was late, would be the probability of him cycling and late over the probability of being late. So cycling and late was 0.008 over the probability that he was late at all is 0.038, which is going to be 4 over 19, or 0.211. So I hope that makes sense.